All right. We're going to go over the review sheet. Start going over it today. We'll finish going over it tomorrow. And the first thing we're looking at is this here. Now, this is one of the first things we've done, and most of the time we forget that this was even a part of this chapter. But we're looking at direct. The first one is direct. And inverse variation. Now, our versions of direct are y equals a times x, or x is equal to a times y. Or we have that a is equal to x over y, or a is equal to y over x. All of these are different versions of direct variation. We also have inverse. Y is equal to a over x, or we can say x is equal to a over y. Or the only other way to write it would be a is equal to x times y. So if we have it in one of these three forms, it would be inverse. Direct and inverse variation. Now neither, there's one giveaway for neither, and that is addition or subtraction. So number 3 is neither. Number 6 has plus also, so it is neither. Well, before we hit any of those, okay. Now I added one here. What would this one be? Y equals 7 over 4. It would not be inverse. What do all of them have to have? What do all the others have? Two main things.
X and Y.
What does that one not have?
X.
So this would be. Yeah, I decided to scroll. But again, any of these here have to have x and y. If they don't, it's neither. So if one of them shows out without a variable x or y, it only has one, it would be. Yeah. Because it's not something we directly covered, but again, all the ones we have with direct or inverse have to have x and y. We have to have two variables. Just the main thing is it just had one variable. Because if it has one variable, it's not going to be direct or inverse. Now let's look at number 2. It would be would indeed be inverse. Because it matches up to our a times x times y. We got number 3 already. Number 4. Number 4 would be inverse. Yeah, so again, that's why having them written down is helpful. We're just matching up formulas. And the last one, number 5. Inverse. We're just matching them up to the form that they have. Questions on 1 through 6. So having those forms written down will be helpful. I won't have them on the board, whiteboard for the test. So having them on your paper will be helpful. 7 through 9 is not on the test. On the full review video, I did go back over how to do those, but they're not going to be on the test, so we're not going to spend time on them here. Number 10, 2x squared over 3x squared minus 4x. Whenever we're simplifying these, we need to factor the numerator and denominator, the top and bottom of this fraction as far as it'll go, and then simplify what's in common. 2x squared, how can we factor it?
2x.
Well, can we factor it? No, it's 2x squared. It's a single term. We can't factor it since it's a single term. Now our 3x squared minus 4x, how can we factor it? We can factor out an x because there's a greatest common factor. And really, when we look at any of these here, we should always look for greatest common factor first. Now, there's not always going to be one, but 3x squared and 4x do have a greatest common factor of x. And when we factor it out of both terms, the 3x squared becomes 3x, our 4x becomes 4, and we get this here. Now, we do have something in common on top and bottom, and that is our x. So the one in the bottom will cancel out completely, and it would remove one of the ones on top, turning it from 2x squared to 2x. And the denominator would be 3x minus 4. That's as simplified as it gets, because the 3x minus 4 is one whole term, and we can't reduce it with anything on top. Questions on number 10? We ready for number 11? 32x squared minus 50 over 4x squared minus 17x plus 15. Our numerator, is our greatest common factor between 32 and 50? 2. 2, when we factor it out, we'd have 16x squared minus 25. Well, we could factor the denominator at this point, do greatest common factor. 4x squared, 17x, and 15. Is there a number that goes into all three terms? No, the only numbers that go into 4 are 2 and 4. Well, 17 is not divisible by 2 or 4, and 15 is not either. However, the numerator, 16x squared minus 25, what's special about it? It's a difference of perfect squares, yes? Because 16 x squared is 4x and 4x. 25 is 5, and our signs would be plus and minus. Now, it seems odd that we would go on and factor it before doing anything with the denominator, but it is somewhat helpful. Because I'm going to put these parentheses down here for now. Because if this is going to reduce, one of these two parentheses has to be what? 4x plus 5 or 4x minus 5. It has to be one or the other, yes? And that's helpful because when we factor 4x squared minus 17x plus 15, it gives us a roadmap. It gives us an idea of what something could be if it's going to reduce. 4x squared minus 17x plus 15. Since the third term is positive, the signs are the same and match the sign of the middle term. They're both negative. Factors of 4x squared. Well, x squared would be x and x. Factors of 4 are 1 and 4 or 2 and 2. If something's going to cancel, what do we need? Well, what's our x's on top? 4x and? I need 4x plus 5 or 4x minus 5 on top and bottom to cancel, yes? Is there any way the denominator in either expression can be 4x plus 5? Well, no, they're both minus, right? So the only thing that could happen is if one of these ends up being 4x minus 5, yes? So I'm going to pick 4 and 1 because that's the only way I can get the x's to match up, yes? Let's look at 15. 15 is 1 and 15 or 3 and 5, yes? 5 in the first, 3 in the second, because if this works out, we now have 4x minus 5 on top and bottom. This is helpful, so if we find one that factors nicely, factor it. Then use it as a roadmap to find the others. Now, it is good to check and make sure, because it's not always going to work out those are the factors we need. Here, 4x times negative 3 is negative 12x. Negative 5 times x is negative 5x, giving us negative 17x, the middle term we wanted. Yes? So it does help us get the factors a little quicker. Now we can fill that in. Now we can cancel what's in common on top and bottom, our 4x minus 5, 4x minus 5. And what that leaves us with is 2 times 4x plus 5 over x minus 3. And that's it. Questions on this here? And if you notice with most of this here, it's all revolving around factoring. Get it factored down, cross out what's in common. And again, this x minus 3 is a single term, so we can't just simplify out with it. We could with the previous one because multiplication, they're being multiplied together. Questions on any of this so far? We're not going to look at 12. I do 12 in the video. And the reason we're not going to look at it is because the sum or difference of 2 cubes is not going to show up on the test. I'm not going to make you solve sum or difference of perfect cubes when simplifying. Because if we did this, it would just be x minus 3 times x squared plus 3x plus 9. And the numerator would factor to x minus 3 and x minus 4. So just factor and simplify. 13. We need to factor and simplify. Now the numerator, x squared minus 4x minus 12, is there a greatest common factor between those 3 terms? Denominator, x squared minus 4. So we'd have x plus 2 and x minus 2. There's no greatest common factor, but it does factor nicely. And whichever one you can find the factors of first, go with it. Because x plus 2, x minus 2, yes? Now we said the numerator didn't have a greatest common factor, so we'll have 2 sets of parentheses because this will factor. Well, if something's going to reduce, we need one of the parentheses to be what? Either x plus 2 or x minus 2. Since the third term is negative, our signs are almost opposite, positive and negative. Only factors of x squared are x and x. Factors of 12 are 1 and 12, 2 and 6, 3 and 4. 2 and 6, because if we're going to have something match up, we need one of them to be 2. No. 2 and 6. Now we can check and make sure. X times negative 6, negative 6x. 2 times x is positive 2x, giving us negative 4x, which is the middle term we wanted. Yes? X plus 2 and x plus 2 cancels, leaving us with x minus 6 over x minus 2. We can't cross the x's out because of the subtraction between the x and 6. And the same thing is true with our x and 2 on bottom. They're stuck together, they're one term. Questions? Because you can almost think of them still with those parentheses. They are stuck together. Questions?
I'll put the plus and minus difference.
Yeah, even if you have them flipped on bottom, you still get to the same spot. Does that make sense?
I had it x plus 2, so it wasn't right.
Even if they don't line up, that's fine.
X minus 6 over. What?
Yeah, because even if we said x minus 2 here, x plus 2, the x plus 2 still cancel out. Doesn't matter that they don't line up.
I don't know what I did. I switched sides or something.
Possibly.
I didn't get what you got.
Probably. Yeah.
Because I had this negative and this positive.
Might have had, yeah.
And then I had this positive, this negative. But this was a substitute. I don't know what I did.
I think,
Probably switched signs.
yeah, switch signs and got a little mixed up. But
I forgot it matters when there's a plus and minus. So I just wrote the 6 and the 2 wherever.
yeah, and then check it. And probably had x plus 6 times x minus 2, which would have given you a positive 4x as the middle term instead of negative.
Make myself a note to check.
Yeah. The only ones I don't normally check are difference of perfect squares because they kind of have a set pattern to them. Works out nicely. But some of them it's good to check. Now, we're not going to look at 14. I did do 14 in the full video. But there's not going to be one exactly like it on the test where we just have one term. They're all going to be like 15 where we have these polynomials, these multi-expressions. And we need to factor. Well, there's some of the parts in 15 that don't factor. That's one that doesn't factor. 2x, it's a single term. What else doesn't factor? Yeah. No greatest common factor. Degree is 1. It's as simplified as it gets. Now, if one of the problems when you're working it is already in a set of parentheses, it's already been factored, 2 sets of parentheses, leave it. Especially with multiplication, division, addition, subtraction. If it's factored in the denominator for addition, subtraction, and it's factored anywhere in multiplication or division, don't multiply back out. Because what are we having to do with multiplication and division first? We have to factor it. So if it's already factored, leave it alone. X squared minus 4x. Greatest common factor. Greatest common factor of x. If you have 2 terms and no constant term, no term without a variable, most likely there's your greatest common factor. Here, greatest common factor of x. X squared plus 3x minus 4. No greatest common factor. And since we do have an x squared term and a constant term, a term without a variable, 2 sets of parentheses with 3 spaces. Our third term is negative, so our signs are opposite. Only factors of x squared are x and x. Now our factors of 4 are 1 and 4 or 2 and 2. It'd be 1 and 4. Which one's positive, which one's negative? One's negative, the 4 is. Because with the 1 being negative, do we have something in common on top and bottom? Yep. And if we check this here, x times negative 1 is negative x. Positive 4 times x is positive 4x, giving us a positive 3x for the middle term, which is what we wanted. Now at this point here, we can multiply them together. We'd have x times x minus 4 times x plus 4 times x minus 1. And on the bottom, we have 2x times x minus 1. Now, there's no reason to multiply through with the 2x, because if something's going to reduce, we need it in factored form. Now, we do have something in common on top and bottom, yes? X minus 1, x minus 1. Anything else? X over x. Now, the 2 would stay there because that's not being affected by it. So the denominator we have 2. And on top is x minus 4 times x plus 4. That's it. So we don't have to multiply the x minus 4 and x plus 4 out. This is it. Questions? Because we're just wanting to simplify it. This is simplified. Yeah. There's no reason to multiply back out. We can just leave it as this here. Yeah. I know some programs, especially if you're checking your work and trying to see getting there, a lot of them will multiply back out, but there's no point to it because we're not asking or trying to go further from here. This is it. Are you ready for the next one? Now, there's only one of these, or one of the four expressions here is a little bit nicer than the others, or a little bit easier to factor, at least in my opinion. Which one do you think that would be? I'd say 2x squared plus 4x, because it has a greatest common factor of, and, which leaves us with x plus 2. That's it. I think it's a little bit easier because we just have a greatest common factor we have to remove, and that's it. Now the others, 3 don't have a greatest common factor. I'm just picking one. So we'll have to do 2 sets of parentheses with 3 spaces. Since our third term is positive, the signs are the same and match the sign of the middle term. Plus and plus. Factors of x squared are and x. Factors 4 are 1 and 4 are 2 and 2. It would work out to be 2 and 2. And if we check this, x times 2 is 2x. 2 times x is positive 2x, giving us positive 4x as the middle term. So that's correct. Where do we want to go next? X. Yep. We'll go with the other numerator. No greatest common factor. Since the third term is negative, our signs are opposite. Plus and minus. Factors of x squared are x and x. We would have negative 1 and positive 4. Because our factors of 4 are 1 and 4 or 2 and 2. Yeah. Because if we check this one, x times negative 1 would be negative x. 4 times x would be plus 4x, giving us a positive 3x that we wanted. The last one, there is no greatest common factor. But since the third term is positive, our signs are the same and match the sign of the middle term, minus and minus. Factors of x squared are x and x. Now we need to pick which factors of 3 we want to use. That's kind of funny, yeah. 3 and 1, because those are the only factors, so we don't have any real choice in that. Question on how we got this here.
So on this set, we need, it's really the same, right?
Combine them, yep, and then say x minus 1 and x minus 1 cancel. X plus 2 and x plus 2 cancels, yes. Leaving us with plus 4. Yes. And that's it.
So what would they want? So, what would they want us to do?
That'd be it.
We
Yeah.
would solve it, like in any level of math, we would solve it.
If we're just multiplying and simplifying, that's it. This is in simplest form.
What would it?
Huh?
What would that be?
I don't know of an exact application that this would be used for simplifying this, but there's probably something out there. I mean, you can find values for this here if you're dealing with proportions or setups, and you can set the x based off a certain amount or length that you can then quantify and fill it in.
Yeah, but that would be that would literally simplify to a number.
Yeah, then it would simplify to a number because
Together x.
we could be talking about a proportion of area to side lengths, or then if we give one of the side lengths or that specific amount that signifies x, it'll give us the rest.
That would be in construction.
Possibly,
So
yeah.
I wonder if people in construction would do that.
Even if not, there's a computer that does it for them. Questions on 16. How do we feel with multiplication? Good? Let's do one more. Because I think 17 is the last multiplication problem before we do division. Now, the x squared plus 2x minus 8, even though it doesn't have a denominator, it's over 1. Out of these other 3, well, all of them, there is no greatest common factor. But one of them is kind of nice in how it factors. And it would be x squared minus 16, because it is difference of perfect squares. You have x and x, 4 and 4, and the signs would be opposite. Now that tells us, hopefully one of the factors on top will be an x plus 4 or an x minus 4, because if we have one or the other, then it will simplify. X squared minus x minus 12. Since the third term is negative, our signs are opposite. Factors of x squared are x and x. Now our factors of 12 are 1 and 12, 2 and 6, 3 and 4. 3 and 4. Now the denominator does help us getting 3 and 4, but it doesn't really help us on figuring out if the 4 is positive or negative. I'm just going to plug them in. And we can check this here. X times negative 3 would be negative 3x. 4 times x would be plus 4x, giving us a positive x. So we need to switch the signs. Because now it would be positive 3x, negative 4x, giving us a middle term of negative x. Yes? Okay. Well, do we have something in common on top and bottom? Yeah. Might as well go on and simplify it out. Because it's over itself. So it reduces to 1, and it is gone. Now we're left with x squared plus 2x minus 8. Third term's negative, so our signs are opposite. Factors of x squared are x and x. Now our factors of 8 are 1 and 8 or 2 and 4. 2 and 4. Which one's positive, which one's negative?
4 positive.
Because if the 4 is positive, we now have x plus 4 on top and bottom, so they would simplify, yes? And if we checked it, x times negative 2 is negative 2x. 4 times x is positive 4x, plus 4x, giving us a positive 2x as our middle term. Yes? And if we multiply them together, we have what? X plus 4 on top and bottom. They would cancel out, leaving us with x plus 3 times x minus 2. And since it's in the numerator, we don't have to put the denominator as 1. We don't have to say this is over 1. We can leave it as this here. Now, if it was the other way and the numerator simplified out completely, we do have to write it as 1. Because 2 over 1 is not the same thing as 1 over 2. So if the 1 is still there in the numerator, we have to put it. And incidentally, if the entire thing simplifies out, it just reduces to 1. Eighteen's not going to show up on the test in that form. We are going to have division, it's just not going to be with monomials, single term expressions. They're going to look more like problem number 19. Huh? Yeah, I need to get more nail polish.
Is that what you use?
Yeah. Now, with division, what is the one key step? Do y'all remember what it was for dividing?
Keep change. Flip.
Keep, change, flip. We keep the first one the same. Change the sign, or change the operation from division to multiplication, and flip the second. Well, it's mainly for this year was working with fractions and dividing and partialing it out and realizing that really dividing two fractions is the same as multiplying by its reciprocal. Yep. Now, for this here, there is no greatest common factor in any of the expressions. This here. No greatest common factor shows up in any of the spots. So we're just going to need a factor. Well, I'm going to start off with x squared minus 3x minus 40. Since the third term is negative, our signs are opposite. Factors of x squared are x and x. Factors of 40. 1 and 40, 2 and 20, 4 and 10, 5 and 8. For time's sake, I'm going to tell you it is 5 and 8. Yep. Now the denominator, x squared plus 8x minus 20. Well, since the third term is negative, our signs are opposite. Factors of x squared are x and x. Now our factors are 20, 1 and 20, 2 and 10, 4 and 5. We could try 4 and 5, but we would get positive x or negative x as the middle term. We need 2 and 10. And the 10 is going to be positive, the 2 is negative. So this is one of the cases where that numerator didn't give us any factors. It hopefully will on the other one here. X squared plus 12x plus 20. Third term's positive, so sign's the same. Match sign in the middle term. X squared is x and x. Well, factors of 20, 1 and 20, 2 and 10, 4 and 5. We would want 2 and 10. Because we do have something in common on top and bottom now, yes?
Oh, I keep looking at the bottom.
Yep.
Looking at the bottom one, I forgot what. 2 and 10. Yeah, 12.
Give us 12. Now the bottom one, third term is positive, signs are the same, match the sign of the middle term, plus and plus. Factors of x squared would be x and x.
Oh,
5 and 8. Because we're matching up with our other numerator.
that's the point.
You're good.
I got carbohydrates.
What's in common on top and bottom? X plus 5, x plus 10. Which leaves us with x minus 8 times x plus 2 over x minus 2 times x plus 8. Now, since the signs are different in both of these here, they don't simplify. Now, if it had been negative x minus 8, then we could factor the negative out and they would match. But here, it does not work that way. That's it. Questions on this here? All right, let's look at these here, addition or subtraction. Whenever we add or subtract rational expressions, the denominators have to be the same. Doesn't matter how they're set up. If we have two things being multiplied together, as long as the two denominators are the same, we can add or subtract the numerators.
This one where you multiply top numerators by 2x minus 1.
So here the two denominators are,
2x minus 1.
and since they're both the same already, yes, we can just subtract the numerators. Now we would normally put parentheses when we subtract the numerators, but since they're both a single term, we don't need them, because we can put them, but they would just drop, and our second term would be this here. Now, interestingly enough, the numerator is factorable. 4x squared minus 1 is factorable. And it is a difference of perfect squares. Because what times itself is 4x squared?
2 plus 1.
So we'd have 2x plus 1, 2x minus 1. And our like terms are?
2x.
And 2x minus 1, leaving us with 2x plus 1. Questions on number 20? Number 21, are the denominators all the same? So we can add the numerators. So we're going to add 9x squared. This 6x minus 1 and 6x plus 5. And again, with addition, we don't have to worry about parentheses because there's not going to be a sign change. Now, when we combine like terms, 9x squared is its only like term. We do have 6x plus 6x is plus. Negative 1 plus 5 is plus 4. So our numerator, so we'd have plus and plus because since the third term is positive, the signs are the same and match the sign of the middle term. Factors of 9x squared, well, we'd have x and x. Factors of 9 are 1 and 9 or 3 and 3. Which one would we want? 3 and 3. Because that would match up with our 3x in the denominators. Factors of 4, 1 and 4 or 2 and 2. 2 and 2. And that would indeed give us the middle term of 12x. What's in common? X plus 2 is in common on top and bottom, which reduces to just 3x plus 2. Questions on this here? We feel good with this so far. All right, we're going to stop there.